All right, let's just jump right in. Today, we're going to tackle two ideas that are, honestly, at the heart of understanding any kind of data: validity and reliability. You know, if you get these right, your conclusions are rock solid. But if you get them wrong, well, your whole argument can just fall apart.
So let's set the stage a little bit. We're living in an age of just information overload, right? We are constantly getting hit with stats, figures, and studies from all sides.
The big question is, how much of it can you actually trust? And that's a really critical question, isn't it? I mean, whether you're looking at a news headline, a business report, even a scientific study, what really matters is the quality of the data underneath it all. So how in the world do we separate what's trustworthy from, well, all the noise?
And that right there is where these two key ideas come into play: validity and reliability. You could almost think of them like the bouncers at the club of trustworthy information. You know, if any data can't pass these two tests, then whatever conclusions come from it, they're built on some really shaky ground.
Okay, I know these words can sound a little abstract, a little academic. So let's make them super concrete. We're going to use a simple but really powerful metaphor to break it all down: the archer's target.
Just imagine an archer, right? They've got their bow, they're aiming for the bullseye. That simple image, that's going to be our key to unlocking what validity and reliability really mean.
So in this metaphor, the bullseye, that's the truth with a capital T. It's the real, correct value that we're trying to measure. It could be anything, really. The actual public opinion on something, the true effectiveness of a new drug, you name it. The bullseye is the goal. It's what we're aiming for.
All right, let's tackle the first one: reliability. And it's pretty simple, really. It is all about consistency.
So, the formal definition is basically about getting the same result over and over and over again, as long as the conditions are the same. If you measure something 5 times, do you get the same answer all 5 times? That's the question at the heart of reliability.
So let's go back to our archer. A reliable archer? They are super consistent. Now here's the thing, their arrows might not even be hitting the bullseye, but they're all landing in the exact same spot, tightly clustered together. That tight grouping, that's reliability.
Okay, so if reliability is all about consistency, then what's validity? Well, validity is all about accuracy. It's about actually hitting the target you were aiming for in the first place.
To put it a bit more formally, validity asks a really important question. Is your measurement actually capturing the thing it's supposed to? It's asking, are you measuring what you think you're measuring? So let's go back to the archer again. What if an archer is valid but not reliable? Well, their arrows might be scattered all over the target, kind of spread out around the bullseye. They're not consistent from one shot to the next. But, and this is the important part, the average position of all those scattered arrows is right on the bullseye. So on average, they're accurate.
Okay, now for the magic. Here's the deal. Neither reliability nor validity is really enough by itself. Real, true confidence in your data, that happens when you have both of them working together. That is the gold standard.
So what happens when we start looking at both of these concepts at the same time? Well, it creates this kind of matrix with 4 possible outcomes. And this table here lays out every single possibility. So first, you could be reliable but not valid. Think of a tight cluster of arrows, but way off in the corner of the target. You're just being consistently wrong. Then you could be valid but not reliable. Your shots are kind of scattered, but their average is right on the bullseye. And finally, you've got the worst case scenario: low reliability and low validity. Your arrows are just everywhere. It's pure noise. But this is the goal. This is what we're shooting for: highly reliable and highly valid. Your arrows are in a super tight cluster, and that cluster is parked right in the middle of the bullseye. Every single measurement is both consistent and accurate. That's the gold standard.
Okay, so this isn't just some abstract theoretical exercise. Understanding the difference between reliability and validity has, massive real-world consequences. Why should you even care about this stuff outside of a statistics class? Because getting this wrong can be huge. This is all about our ability to make good, sound decisions in medicine, in business, in our whole society, based on information we can actually trust.
Just think about a medical trial for a new drug.
You absolutely need a test that is reliable, it has to give the same result over and over, and it has to be valid, meaning it actually detects the disease it's supposed to. Or what about an election poll? The questions have to be reliable so they get consistent answers, but they also have to be valid so they accurately capture what voters really think. In every single one of these examples, the stakes are just incredibly high.
So here's the bottom line. If your data is reliable but not valid, you're just confidently marching off in the completely wrong direction. And if it's valid but not reliable, your results are probably going to be too noisy to be useful for anything. Without both, you're basically flying blind. You know, this quote just sums it all up perfectly. The goal is not just to get a number. The goal is to get a number you can trust. We're surrounded by numbers all day long, but they are not all created equal. The point isn't just to get the data, it's to make sure that data is something we can actually rely on.
So here's a little challenge for you. The next time you see some bold claim or a shocking statistic, just pause for a second. Don't just take the number at face value. Ask yourself those deeper questions. Is this measurement reliable? Is it valid? In other words, are the arrows consistently hitting the bullseye? Because once you start answering those questions, that's when you can start to see the world with some real clarity.